Hello grade 12s. In this video we are going to look at work done on an object by a constant force. The work done on an object by a constant force is defined as F multiplied by the delta X multiplied by the cos theta, where F is the magnitude of the force and the delta X is the magnitude of the displacement, and the theta is the angle between the force and the displacement. Work can be done when there is a force applied. If there is no force applied, there is no work done. When the object moves, so if there is no displacement, there is no work done. When the angle is not equal to 90 degrees, so if the cos of 90 degrees is equal to 0, therefore when the angle between the applied force and the direction of movement or the displacement is 90 degrees, there will be no work done. Now we're going to look at the example of this formula. So the first example, an object is being pulled to the right through a distance of 5 meters. And then we are going to calculate the work done by the applied force. So to calculate the work done by the applied force, we therefore have to say the work done by the force is equal to the force multiplied by the displacement and then the cos of theta. So now the force we are talking about here, the applied force in this question is 10. So we therefore have to take our 10 multiplied by our displacement. Our displacement is 5. We multiply by 5. Then now we are going to multiply by the cos theta, which is the angle between the applied force and the direction of movement or the displacement. So now we can see the applied force goes to the right and the displacement also goes to the right in the same direction. They're parallel. So in this case, if they goes in the same direction or they're parallel, the angle is 0, so cos is 0. So therefore our answer for this is going to be 50 joules. Now let's take the second example. Calculate the work done on the force applied at 30 degrees on the object. So we can see for this object, the force is applied at 30 degrees and the direction is also to the right and the displacement is 5. So to calculate the work done, we need our formula. The work done by the applied force is equal to that force in question times the displacement and then times the cos of theta. So this gives us, now the applied force is 10 newtons and the displacement is 5 multiplied by the cos of the angle between the force and the displacement. We can see that the displacement goes to the right and the angle of the force and the displacement is 30 degrees. So we therefore say 30 degrees, cos 30. So when we multiply this, we shall get 43,3013 joules. So that is our answer for example 2. Now, example 3. We're going to look at the work done by friction. So, work done by friction is equal to that friction multiplied by the displacement multiplied by the cos theta. So now our friction in this case is 2. Our displacement is 5. And now the cos of theta. Now the direction of the displacement is to the right, but we can see the friction goes in the opposite direction. So therefore, the angle between the friction and the direction of motion is 180 degrees. So we therefore say cos of 180 degrees. So this gives us negative 10 joules. Now the next example. The applied force is applied at an angle of 60 degrees to the left, but the direction of movement is to the right. So if I have to apply the force to the right at an angle of 60 degrees, but my object move to the right, I apply the force to the left, but the object move to the right. So the angle between the applied force now and the direction of movement is going to be this angle here. So now to get this angle, this is a straight line, and this part of it is 60. This part of it is 60 degrees. So to get this angle here is going to be 180 minus 60, which gives us 120 degrees. So the angle between the force and the displacement or direction of motion is going to be 120 degrees. So now the work done by the applied force is equal to the applied force, changing displacement, changing delta x, and then cos of theta. So now we have the applied force to be 10 and the displacement to be 5. And we have the cos of theta to be cos of 120 degrees. So this gives us negative 25 joules. Now the next question, work done by the normal force. The normal force acts at 90 degrees. It acts perpendicular to the surface. So looking at the normal force in direction of movement, we can see it forms an angle of 90 degrees. So to calculate the work done by the normal, we just have to take that normal force and then multiply it by the displacement and then cos of theta. So now the normal force, which is 10, multiplied by 10 multiplied by 5 and multiply by cos 90. And cos 90, because of cos 90, everything is 0. So 0 joules. So when the angle between the force and the direction of motion or the displacement is 90 degrees, no work is done. The next is work done by gravity or weights on the horizontal surface. So the work done by gravity on the horizontal surface is the gravity, and then change in this in the delta x, which is the displacement, and cos of theta. So now the weight is also can be also defined by the mass times the acceleration due to gravity constants. So therefore, this object here, let's say the mass of this object is 5 kg. So work done by the weight is therefore going to be the mass times the acceleration due to gravity. So the mass is 5 times 9,8. That is the force. So multiply by the displacement, which is 5, and multiply by the cos of 90. This also gives us 0 joules. So that is it. And one thing we have to take note of is work done is a scalar quantity. It needs no direction. So if the work done is positive, it means energy is gained. And if the work done by the force is negative, it means energy is lost. And friction always does a negative work done. Thank you.